Topic of calorimetry, the first thing that we come across is what is the meaning of the word calorimetry. So the answer to the question is study of measurement of heat is calorimetry. So study of measurement of heat. So that is the meaning of the word calorimetry. After that, the first thing that we are going to see is the difference between heat and temperature. Okay, so in heat and temperature, the first thing will be the definition. So when you talk about any substance, a substance is composed of many atoms and molecules. Now these atoms and molecules are in constant state of vibration. So the vibration that causes them, okay, that is called as the kinetic energy, vibrational kinetic energy. And the molecules are also bound together with a force that will be the potential energy. So when you add all this energy together of all the molecules of a substance, that will be the heat content of the body. Okay, so the heat will be the total of the molecular kinetic energy and the potential. Then when you talk about temperature, temperature is the average kinetic energy of the body. So the total internal energy is the heat energy, and the total average of the total kinetic energy of the molecule will be called as the temperature. So the first point is the definition. The second point is unit. SI unit for measurement of heat is joule. Okay. The other units are calories. Then for temperature, it is Kelvin. Okay, and the other units are degree Celsius and Fahrenheit. Then you can talk about some differences that heat is additive, okay, whereas temperature is a non-additive quantity. Now, what is the meaning of that? Let's, for example, on a food packet, they say that 100 grams contains so many calories and so on. So suppose, for example, if you are eating a biscuit, now this biscuit is giving you 50 calories, okay, and then if you eat one more, you will get 50 more calories. That means you are getting a total of 100 calories, okay. On the other hand, if you take a glass of water, the water contained over there is 20 degrees Celsius. And if you take another glass of water, this also is 20 degrees Celsius. Now, if you mix them up into another container, okay, just now when you add these two glasses of water together, the temperature is not 40. Okay, it's not adding. That does it. Temperature doesn't work that way. So temperature is a non-additive quantity. So that's one point of difference between temperature and heat. Okay. What follows after that is definition of calorie. Now, in definition of calorie, we have 1 gram of water. Okay, 1 gram of water, which is at 14.5 degrees Celsius. 1 gram of water at 14.5 degrees Celsius. If it is given 1 calorie, the temperature will become 15.5 degrees Celsius. So the amount of heat required to take 1 gram of water from 14.5 to 15.5 degrees Celsius is called as 1 calorie. Then when we talk about kilocalorie, it is 1 kg of water, okay, from 14.5 degrees Celsius to 15.5 degrees Celsius. Now, just a minute. So when you have heat supplied to a substance, okay, like for example, over here, I've drawn some substances. So primarily what happens is when heat is supplied, okay, the vibration of these molecules will increase. Plus, they will also try to, increase the separation between them. So that means if you are supplying Q amount of heat, now in this Q amount of heat, you will have some amount of heat that is used for increasing the temperature, okay, and some amount of heat that is used to increase the separation. Now, when you have increasing the separation, then that will lead to increase in potential energy. Okay, that means the potential energy of the substance will means the change of state will happen. Now, when I say 14.5 to 15.5, all that energy is used only to increase the temperature. That means that will increase the vibrational kinetic energy of water. Okay, now this is a characteristic of water, right? Yes, you had a question?
So why do we say from 14.5 to 15.5 only? Why can't we say like from 5 to 6?
Yeah, that's what I just said. Did you, means I said it's a characteristic of water.
So, but
Okay.
like that is pertaining to the anomalous expansion, right? Which is 0 to 4. So like we can use any temperature above that.
No, you are mistaken. 0 to 4 is about melting and freezing. Okay. So means in that case, the water is contracting and expanding. And at 0 degree, it is changing the state. But when you take water from 0 degree and when you increase the temperature to 100 degree, when water starts boiling, in between, there is change happening. Okay. So the separation between the molecules of water when it is say at 10 degrees Celsius and separation between molecules of water when say it is at 80 degrees Celsius, it's not same. It's gradually changing. Okay.
Oh,
So
okay.
there is some energy that is spent to increase the vibration and some energy that is spent to increase the separation. So 14.5 to 15.5 is specific, and that's what you need to remember for a definition of 1 calorie. Also, understand that the reverse is also true. Okay, that means if a body is losing heat, then its temperature will drop, and the molecules will come closer. So that also happens. Okay, what happens after that is
So just one question.
yeah.
So if they ask us to write the definition of calorie, which one do we write since there are two?
This is calorie and this is for kilocalorie. Okay.
So, but in the textbook, they've said that 1 calorie is the quantity of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. And they said that 1 calorie is the heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 Celsius.
Yeah. So stick to this. Okay. 14.5 to 15.5. Of course, there is no much greater change in the amount of heat required. It is negligible, but this is a accurate definition. Okay, like for example, the accuracy depends upon what you want. Like here, 1 calorie is given as 4.186 joules. In our calculation, we are going to round it off to 4.2 joules. Okay, so that's the accuracy that we are looking for. But yes, I repeat again, for definition, stick to 14.5 to 15.5.
So
okay. Yes.
So when the separation between the molecules increases, so can you repeat what happens to the potential energy over there?
The potential energy will decrease.
So what is the reason for that?
Potential energy is defined as the attraction between the molecules. Okay, the force with which they are pulling each other. So if you are supplying energy to them, you are moving them apart. Yes, my lord.
So will that potential energy count in 14.5 to 15.5?
No, that's what I was saying, that from 14.5 to 15.5, that the energy that is supplied is only used to increase the temperature. There is no change in the potential energy.
Okay.
And something that we are going to study in the next exercise, but just to tell you, when water reaches 100 degrees Celsius, okay, you know that you will continue to supply heat, but the thermometer will not show any change, okay, but heat is supplied, and that time all the heat that is used to increase the separation. So in that case, there is no change in temperature, but everything that is used to change the potential energy. Okay, so that's also an example. Whenever there is a change in phase, there is no change in temperature. Something that you have studied in the lower classes as well. Okay, then you have 1 joule. Okay, so 1 joule is 0.24 calories. Fine. Okay. The next is concept of heat. Now, in concept of heat, we have the following things. I'll just explain them with the help of a simple explanation. So let us consider two beakers over here. Okay. So this is A, this is B, and there is a burner is there supplying heat. Okay. And let's say in one beaker you have this much water, and another beaker you have this much of water. The temperature is measured with the help of a thermometer, and in both the beakers the temperature is 30 degrees Celsius, and it is heated till the temperature becomes like say 80 degrees Celsius. Okay, so if you take QA is the heat taken by beaker A and QB is the heat taken by beaker B, I hope you all agree with me when I say that QA will be greater than QB. Okay, so therefore you have heat is proportional to mass. That means when you have more mass, the heat taken or heat required would be more. Okay, so that's one point. Now, if I repeat the same experiment, this time I can have the same amount of water, and beaker A, we can continue to heat it from 30 to 80, and beaker A, sorry, will be 30 to say 50 degrees Celsius. So now you will know that A will have lesser heat. Okay, I hope you agree with that, because it is heated to a smaller rise in temperature, whereas the other beaker is heated to a lower rise or to a higher rise in temperature. And both being water, okay, both being water, the material is same. So we can write that amount of heat is dependent on the change in temperature. The same thing goes for cooling also, right? Okay. Now what we can do is, suppose we are assuming it to be some other substance over here. Okay, this can be any liquid other than water, some other liquid is there. And I have, I've drawn the diagram to show you that it is same volume, same mass of the liquid, right? This is also heated, water is also heated from 30 to 80, and the other liquid is also heated from 30 to 80. The mass is same, the rise in temperature is same. So I hope you will agree that we don't know whether which one will be greater or which one will be smaller, but they'll not be same. It will not be same. Okay, so that means the amount of heat, it depends on the material which you are heating. Okay, now all this thing together is written as MC delta T. Okay, where M, you know, stands for mass, delta T stands for change in temperature, and over here what we are going to see is small c, which depends on the material, is called as specific heat capacity. Okay, Now, we are going to study a little more about specific heat capacity. So before we study that, let us first find the unit for that. So if I keep C on one side, and then I'll have Q, M, and delta T. So the unit will be, so this is measured in joule. This is measured in kilogram, and this is measured in Kelvin. Okay, so therefore the SI unit of C will be joule per kg per Kelvin. That will be the SI unit. Okay, and how will we define it? This is similar to the definition we studied in current electricity about resistivity or specific resistance. So if you assume the mass to be a unit mass, and if you assume the change in temperature to be a unit rise, okay, now this is also very clear to understand that the change in temperature 1 Kelvin is equal to 1 degree Celsius also. Okay, I hope you follow that. That means if the temperature goes from 30 degree to 31 degree, that means a rise of 1 degree Celsius. The corresponding rise in Kelvin will also be 1 Kelvin. Okay, so if mass is 1 kg, change in temperature is 1 kg, then you will have C equal to Q. Okay, that will be numerically, right? Okay, so I would just repeat one thing. We had resistance as resistivity L by A. So we defined resistance as L into A upon L, R into A upon L, and we took A as 1 unit, L as 1 unit. So R was rho was equal to R. So that's how we defined specific resistance. So similarly, to define specific resistivity, so specific resistivity, specific heat capacity will be the amount of heat required by a unit mass to increase its temperature or change its temperature by 1 Kelvin or 1 degree Celsius. Okay, that's the definition. Yes, what's your
So
doubt?
can you just
So
Yeah.
I was asking that 1 Kelvin is lesser than 1 degree Celsius, right? Because 0 Kelvin.
No, I'm talking about change in temperature. Okay, 30 degrees Celsius to 31 degrees Celsius is 1 Kelvin rise. Okay, so that will be 303 Kelvin to 304 Kelvin. That will also be 1 Kelvin rise. Do you follow that?
so basically whenever it's 1 degree rise, it will always be 1 Kelvin rise also.
Yeah.
So if then 3 degree rise, there'll be 3 Kelvin rise, like that.
Yeah, rise you have to say, not 3 degree temperature. So if the temperature goes from 47 degree to 48 degrees Celsius, there is a 1 degree rise. So what is 47 equivalent of Kelvin? 47 degree means what? It will be 320 Kelvin. So it will become 321 Kelvin. Again, there will be a 1 Kelvin rise.
Okay, sir.
Yeah. So delta means change.
So
Okay. Yeah.
So in the diagram you have drawn in the concept of heat, so there you said that the heat in A will not be equal to heat in B. So but the mass, volume and density of both is same, then how is it possible that like they will have different heat?
So I said the mass is same and the rise in temperature is same. So if I take 1 kg of water and heat it from 30 to 80, and I took 1 kg of oil and heat it from 30 to 80, then the heat required by water to go from 30 to 80 will be different, and heat required by oil to go from 30 to 80 will be different.
So but what is the reason for that? Because like if we use so the formula of volume also, then like the volume, mass and density will be the same. So what Like
Yeah, but
nothing
that
makes
is
it.
nothing to do with how the substance conducts heat.
Oh, okay.
Like you have studied about conduction, convection, radiation. So say for example, there is a fire going on here. Okay, and if you are asked to hold a metal rod into it, will you hold it?
No,
Will
sir.
you? Why?
So because the heat gets conducted and then I'll get more.
Faster, right? It will get conducted faster. Now,
Yes,
instead of metal, if it was a wooden rod, will you hold that?
yes. So because like the heat
Yeah,
isn't conducted. Oh,
because the
okay.
heat will
Okay.
conduct it slower, means
Yes,
you
sir.
can hold it for some time.
So wouldn't it burn?
So no, I'm not asking you to hold it like till it burns and this part burns and it's like remaining part is left burning. I'm just trying to make you understand about this conduction. That means uh, a simple example would be you go on a beach. Okay, so if you go during the afternoon time, the sand is pretty hot. You can't walk barefoot in the noon time on the beach. But at the same time, if you go inside water, it's cooler. Okay, so the sun is beating on two things, on the sand as well as on the water. But sand gets hot faster, so it depends on the material. Okay, now I'll give you an example. Specific heat capacity of water is 4,200 joule per kg per Kelvin. So that is the specific heat capacity of water, which is among the highest. So the question will be asked, like, what do you mean by that? What is the meaning that water has specific heat capacity 4,200? Now, this is similar to the question that we had discussed earlier in the topic of light, that, refractive index is 2. What do you mean by that? So similarly, specific heat capacity of water is 4,200 joule per kg per Kelvin. What is the meaning of that? So it means that if you take 1 kg of water, okay, and suppose it is at 40 degrees Celsius, and if you supply 4,200 joules to it, then the temperature will become 41 degrees Celsius. Okay, so that's the meaning of that. And now, on the other hand, if you take copper, so copper is around 300 joule per kg per Kelvin. So that means if you take 1 kg of copper, that is like a copper plate, and if you supply only 300 joule, then the temperature will rise by 1 degree. So water indeed has a very high specific heat capacity, and that is the reason why you can try this, especially now, nowadays where the temperature is quite low in Mumbai comparatively. It will take longer for the water to boil because the starting point itself is around 20 degrees Celsius for water, which otherwise on a regular day it is higher. So therefore it will take that much less energy, and that will take that much less time to heat. Do you follow what I'm saying? Okay. And in a similar way, another thing to make you little conscious about not wasting electricity. First of all, when you are cooling water in a refrigerator, that means if you cool 1 kg of water, which is say at 25 degrees Celsius to around 5 degrees Celsius, that means 20 degree is the drop in temperature. Now, for this much drop, okay, and for each degree, imagine 4,200 joules. So that means 4,200 into 20, okay, that means it will be 84,000 joules. You are wasting this much energy to cool water. And what happens when it goes inside your body again spend energy to bring it to 36 degrees Celsius. Are you following that? Okay. So try and avoid drinking cold water every time. It is good for your health also to drink normal water or warm water. And you will end up saving electricity also, because 1 kilowatt hour is 3.6 into 10 to the power 6 joules. So the amount of water that you're cooling in the refrigerator, okay, which sometimes may get wasted also. So quite a lot of energy is being wasted. So that's just like to have a little general sense. Yes, there was a question. Anyone has a question?
So,
Yeah.
so can you again explain that thing, like if they ask what is the meaning of the specific heat capacity is 4200 joule per kg per Kelvin, then what do we have to write?
Yes,
Yeah, it means if you take 1 kg of water, okay, 1 kg of water, then for 1 degree rise in temperature, 4200 joules of heat will be required.
Oh, okay, sir.
Okay, that is the meaning of specific heat capacity of water. Yes.
The specific heat is what it already has in itself.
Specific heat is a characteristic of a substance. That's why it is called as specific heat. Okay, because if you see in the textbook on page number 265, they have given you a table. Now that table is, so obviously these are characteristics. That means these are what you say, they depend on substance. So for example, lead, it is 130. So if you supply 130 joules to 1 kg of lead, the temperature will go up by 1 degree. Okay. And the same with copper. Copper is around 399. So if you supply that many joules for 1 kg of copper, the temperature will go up by 1 degree Celsius. Okay, so this is specific heat capacity. Now we will introduce another term called as heat capacity. Now heat capacity is a capital C and a prime, and that is equal to mass into specific heat capacity. Okay, so obviously it will be different for each body. Okay, like for example, why this is relevant also. When you talk in terms of heat capacity, okay, we talk in terms of things that are going to get heated, like the engine of a car, engine of a plane, or any machine that has been used. So if you are talking about a car engine, okay, so that has a specific mass. So that therefore the manufacturer will consider the engine, and it will talk in terms of how much after how long will the car get heated. So that obviously the engine is different for different types of cars, so the time will be different. So rather than talking about specific heat capacity, they talk about heat capacity. So that will take into account the mass of the engine. Okay, again, this is a very crude way of explaining, because when you talk about an engine, it has a definite shape, definite design, it will lose heat. But I'm trying to tell you that something which depends on the mass, or something that will depend from body to body. Okay, so that is another term called as heat capacity. Now, since it is mass times specific heat capacity, that is joule per kg per Kelvin, so therefore its unit is only joule per Kelvin. Okay, so that unit is joule per Kelvin. And how will you define heat capacity? So heat capacity is amount of heat required to raise the temperature of the body by a Kelvin, or by 1 degree Celsius. Whereas when we are defining here specific heat capacity, we talk unit mass. We express unit mass. Okay. Yes, Milord.
So specific heat capacity is for raising 1 degree Celsius of 1 kg and heat capacity is for the whole body.
Yeah, for the body. So you will not use the word unit mass, we'll use the word body. Okay, so difference between specific heat capacity and heat capacity is generally asked. Okay, so that is a part of this. Right. Okay. The next part that we are going to discuss is there are consequences of high specific heat capacity of water. Okay, now there are consequences, there are some applications also. So, water being a very high specific heat capacity, that means it takes a lot of heat to heat water. And that is the reason why one good part is all of water doesn't boil at once. Okay, so we receive rainfall like in India around 3-4 months of the year, but the water that it gives lasts for the remaining months. Okay, so that is because water has a high specific heat capacity, so it will not evaporate all at once. So that's one advantage. Another point is to have a pleasant weather. Okay, we are fortunate to stay next to a ocean. So the Mumbai city is closer to the sea. So therefore, what you have studied in geography, okay, there are land breeze and sea breeze. So the sea, being water, takes a lot of heat from the sun without increasing its temperature. So there is a kind of low pressure there. On the land which is hot, there will be there will be a low pressure over here and a high pressure over here. Okay, low pressure because the hot air will rise up and there will be a breeze blowing. Okay, and the reverse happens in the evening when the sun set and the land becomes cooler. So because of this, there is a moderate weather when there is a good wind flow in areas near the ocean. Then there are various other examples like water being used as an effective coolant. So say for example, this is a machine and you have copper pipes going around the machine like this. Okay, and in the copper pipe you have water. So what the water will do, water will absorb the heat from the machine and take it for itself. So the water enters and the water exits. So by absorbing the heat by itself, its temperature doesn't go as much. Okay, earlier it was used in cars also. Nowadays they have a cooling liquid, uh, which is instead of water that they use. Okay, so this is also a high specific heat. Then you have those heat pack. Okay, when there are certain body part which are paining like the back, you must have seen that there is a rubber bag. Inside you pour hot water and that can be kept on the part which is paining or swollen. Okay, other example is farmers. They fill their fields with water in cold places. Okay, so that the crops will not wither. Because if the crops are there on a cold night, the crops will freeze. Whereas water, because of high specific heat capacity, doesn't freeze all at once. Okay, then of water, there are other consequences of metal as well. Okay, like for example, the electrical iron that we use in our house. So that electrical iron has a thick metal base. So this thick metal base will have a high heat capacity. Okay, so because of the high heat capacity, what it will do is it will supply heat at a lower rate for a longer time. Okay, supply heat at a lower rate for a longer time. Remember that. If you have a thinner metal plate, then the heat that is because of the coil, okay, there is a heating coil which we studied in current electricity, nichrome. So all the heat of the heating coil will be transferred immediately because of a thin plate, and that will cause it to burn the clothes. And the same thing or the same logic is there in a cooking pan. Okay, if you ask anyone in your house who cooks food, that they prefer a cooking pan which has a thicker base. Okay, right. So these are some of the due reasons which you can expect in the exam. Any questions on this?
So we have to mention specific heat capacity for all of them.
Yeah, that's one point. But in the second point, you're expected to explain in short, like why is water used as an effective coolant? What are the high specific heat capacity? That's one point. The second point is the water will take away the heat from the machine by its own temperature not rising as much. Okay, that's why it is a coolant. So here, why do you have a thicker base? Because it has it will have the high heat capacity. So keep in mind, in the earlier examples, we use high specific heat capacity of water. Over here, there are thick metal plates. Thick, so more mass. More mass means more heat capacity. Okay, right.
So
So that
Yeah.
whole calorimeter part is cancelled, right?
No, it's there. We will discuss.
The concept of temperature.
Concept of temperature as in?